You are surrounded by computers right now. And no, I'm not talking about your phone or your laptop. I'm talking about the secret computers, these tiny little brains hidden inside pretty much every electronic thing you own, just quietly running the show. So let's dive in and find out what they are. Seriously, just look around you. Think about all the gadgets in your life. Your home, your car, your office. I mean, they're just packed with electronics, right? But what is it that actually makes them smart? Well, that's the big question we're going to tackle today. And it really all boils down to this one question. What could your microwave, your TV remote, and your car's dashboard possibly have in common? I mean, think about it. One heats up your leftovers, one lets you flip channels, and the other tells you you're about to run out of gas. They seem totally unrelated, but are they? Well, here's the answer. The invisible thread tying them all together is this. Every single one of them has a tiny, dedicated computer inside, a little hidden brain whose entire job is to do one thing and one thing only for that specific device. You know, like counting down the timer on your microwave or sensing that you just pressed the volume up button. Okay, so this tiny brain actually has a name. And honestly, it's one of the most critical parts of modern engineering, even though most folks have never even heard the term. So let's get to it. What are we actually talking about? It's called a microcontroller. And I absolutely love this description for it. A computer on a single chip. Because that's exactly what it is. Just picture it. You take all the main parts of a big desktop computer, the processor, the memory, all the ways it connects to the outside world, and you shrink it all down onto a single chip that's smaller than your fingernail. That, right there, is a microcontroller. Okay, now here's where things can get a little confusing, so let's clear it up. You've probably heard of a microprocessor. That's the big, powerful brain, the CPU, inside your laptop. So what's the difference? Well, a microprocessor is just the brain. It's only the central processing unit. It needs a bunch of other separate chips for memory and to talk to things like your keyboard and screen. But a microcontroller, that's the whole shebang. It's a completely self-contained system. It has the CPU, the memory, and all the input-output stuff built right onto that one single chip. And this all-in-one package is really made of three key parts. First, you've got the processor, the CPU. That's the brain, the part that does all the thinking and the math. Then you've got the memory. This is where it keeps its instructions, its knowledge, and any temporary data it's working with. And finally, and this is super important, you've got the senses, the I/O peripherals. This is how it interacts with the real world, letting it feel a button press, read a sensor, or turn on an LED. But here's the really interesting part. Microcontroller isn't just one thing. It's not a one-size-fits-all deal. Nope, there's a whole family tree of them, a huge variety, and each one is specifically designed and tweaked for different kinds of jobs. We're talking everything from the super simple to the shockingly complex. So, how do engineers pick the right one for the job? Well, they basically classify them in a few key ways. The big ones are its bit configuration, which is just a fancy way of saying how much data it can chew on at once, its memory setup, and something called the instruction set, which is like the basic language the processor speaks. Let's start with that bus width, or bit configuration. This is probably the easiest way to think about its raw power. An 8-bit microcontroller? Think of it like a quiet, single-lane country road. It's perfect for simple jobs that don't need to move a lot of data. A 16-bit is more like a 2-lane highway, right? It can handle more traffic, more complex jobs. But a 32-bit? Whoa, that's a multi-lane superhighway, built for serious speed and heavy, data-intensive performance. And this brings us to another cool difference, the instruction set. This is all about the philosophy of how the chip thinks. On one hand, you have CISC, which stands for Complex Instruction Set. The idea here is that one single command can trigger a whole bunch of steps. It's powerful. On the other hand, you have RISC, the Reduced Instruction Set. This philosophy breaks every task down into super simple, bite-sized instructions that execute incredibly fast. So what's the takeaway? It's really a trade-off. Do you want powerful, multi-step commands or simple, blazing fast ones? All right, that's enough of the techie stuff. Let's bring this back down to earth. Where do you actually find these different types of microcontrollers out in the wild, in the stuff we use every single day? Remember those 8-bit chips, the country roads? Well, they are the absolute unsung heroes of the modern world. Seriously, they're in your keyboard, your mouse, your remote control, your coffee machine. Pretty much any gadget that has a simple, repetitive job is almost guaranteed to be run by one of these super cheap, super reliable little brains.
Now, when the job gets a little smarter, you level up to 16-bit. These are for things that need a bit more precision. Think about a digital thermostat that has to keep the temperature just right, or a portable medical device that's tracking your vitals, or maybe the controls for a big machine on a factory floor. They really hit that sweet spot between performance and cost.
And then you've got the big guns, the 32-bit powerhouses. These are reserved for the really tough, really complex jobs. You know how smooth your car accelerates? Yeah, you can thank a 32-bit microcontroller for that. It's making thousands of tiny adjustments every single second to keep the engine running perfectly. Things like advanced robotics, high-tech drones, modern gaming consoles, they all need that kind of horsepower to give us the insane speed and responsiveness we've come to expect. So when you kind of zoom out and look at it all, you start to see the huge picture, right? These aren't just little electronic parts. They are the quiet, invisible engines that literally make our modern world tick. And why are they in everything? Well, it really boils down to four key things. First, they are dirt cheap. We're talking pennies sometimes. Second, they're minuscule, so you can stick them just about anywhere. Third, they barely use any power, which makes them perfect for anything that runs on a battery. And finally, because they're designed to do just one job, they are rock-solid reliable. And all of that leads to a pretty mind-blowing fact. Forget about phones and laptops. Microcontrollers are, without a doubt, the most common type of computer on the entire planet. Not even close. Billions, with a B, are made every single year, just silently weaving a little bit of smarts into the very fabric of our daily life. So that leaves us with one last huge question to chew on. We're all hearing about the Internet of Things, right? This future where billions more devices, everything from our light bulbs to our cars to our cities, will all be smart and connected to each other. And guess what? The little brain inside every single one of those things is going to be a microcontroller. So the real question is, what happens next? How is this gigantic, invisible network of tiny, dedicated brains going to shape our future? It's definitely something to think about.